Good day, grade 11s. Today we are going to look at finding trig ratios when given a variable. Okay, what I'm talking about is something like this, where you are given the trig function here with an angle, and then instead of having a decimal or a fraction, you are given a letter like this. And then you are expected to then find the other trig ratios in terms of t. So that means like this question is saying, it says find, given that cos 20 degrees is equals to t, find the following in terms of t. So this in terms of t means your answer must have a t. So you're not going to have a 0.5 or a or any other fraction. Your answer must have a t. So how do we go about doing this? So the first thing that you will do is, when you are given this information, you use this information to draw a diagram on the Cartesian plane. Okay, so how do you do that? This is cos 20, which is equals to t. So that's what I did here, cos 20, which is equals to t. But now I know that this is supposed to be a fraction, so I've made it t over 1. Okay, because over 1 doesn't change that this is still t. And then from there, I know that the t means, because this is cos, it means t is the adjacent and 1 is then going to be the hypotenuse. So on the Cartesian plane, okay, on the Cartesian plane, I know that this is going to be on the first quadrant because 20 is an acute angle. So I will draw this on the first quadrant. Okay, so I do my 20 degrees like that, and then the line that indicates the hypotenuse, and then t is the adjacent. So I've just completed this side to make it a complete triangle. Right, step number 2 says find the missing side using Pythagoras. Because you are going to have two sides, we don't need it's not sides, it's just side that is missing. Okay, so find the missing side. So in this case, the missing side was the opposite, which I have indicated here. So this was not there, so the triangle looks like that. So this side is empty, so we have to find the opposite. So 1 squared hypotenuse squared is equals to this side opposite squared plus t squared. Then you make opposite the subject, so t squared comes that side, so opposite squared is equals to 1 minus t squared. Okay, so if I'm looking for the opposite, then I have to take the square root. So the opposite is the square root of 1 minus t squared. Then once you have found this missing side, you put it on your diagram. Sometimes you will have the opposite and you are not going to have the hypotenuse, or sometimes you can have these two and not have the hypotenuse. So you have to then use the sides that are given to find what is missing. And then once you have found it, you then put it in your diagram. Please don't forget, because you're going to then use this diagram to answer the questions. Okay, so let's answer the question. The first question was find sine 20 in terms of t. Sine 20, so that means I am here. Sine is opposite over hypotenuse. So my opposite is 1 minus t squared. So you see, if I hadn't calculated this, then I wouldn't be able to answer that question. So t's square root of 1 minus t squared, my hypotenuse is 1. So this divided by 1 will just give me 1 minus t squared under the root sign. So that is your answer, and it is in terms of t because we have a t in our answer. Okay, then the next question says find tan 20. Again, you come back to your diagram. Tan 20, tan is what? That's why I say here, use your diagram and soccer tool to find your answers. Okay, tan 20 is opposite. Tan is toa, so it's opposite over adjacent. So opposite is what? The opposite is the square root of 1 minus t squared, and the adjacent is t, so it's going to be over t. And then there's nothing I can do to simplify that, so my answer will just be what it is, like that. Okay, Then this one says cos 160. You'll see that I have written here that some may need reduction first. So 160 is not an acute angle, so we need to reduce this. So how do you do that? You know by now, 160 is in the second quadrant. So angles of the second quadrant are calculated as 180 minus theta. So we use that to find what theta is going to be. So cos in the second quadrant is negative. So that's why I have that negative. So please don't forget, start with the sign of that function in that quadrant. So cos is going to be negative in the second quadrant. So that's what I've written. Then I reduce the 160. So if I reduce 160, it will give me 20. So it is now negative cos t. Now, cos t I'm already given as what? Cos 20 is equals to t. So that means this I can now replace and write in as t. So my answer here is going to be negative t. Okay, D is cos negative 200. Again, before we can use the diagram, we have to fix this first. Okay, remember we said cos negative theta is equals to cos theta. This we just drop the negative sign. Okay, so the first mark that you will get is for fixing that negative. So cos 200 will give you a mark. Then now you can see 200 is not an acute angle, so that means we have to reduce. So 200 is where? Is on the third quadrant. So my angles at third quadrant is 180 plus theta. Please don't use 270. It's going to confuse you. So or any other number. It's just 180 plus theta. It's easier like that. Okay, so 200, that means 200 is equals to 180 plus theta. So we want to find out what that theta is. So we solve for theta, 180 over there, and then theta is equals to what? Is equals to 20 degrees. So cos on the third quadrant is negative. So that is what I've written here. Cos is negative, and then it will be, the cos comes back, and then instead of 200, I write the 20 that I have reduced it to. And then again, cos 20 is t. So in the place of cos 20, I just write t, and then I have answered the question. Okay, the last one, E, we have sine 250. Sine 250 is on the third quadrant. So what do? We reduce, because this is not an acute angle. So a third quadrant, 180 minus theta. So that means theta is equals to what? 70. So the first thing that you will do is to write that answer in reduction form. Okay, so sine in the third quadrant is negative. So that's why here I have a minus. So it's minus sine. And then in the place of the 250, I'm going to write 70. Now, we don't have 70 on our diagram. Well, it is there, but it is up here. So that means 70 is this other part that's missing to complete the 90 degree. So that means you are not working in this triangle. You are working with this other one that we spoke about that changes the sign to cos, because now what was the opposite becomes the adjacent, and what was the adjacent becomes the opposite if I am now on this triangle here where 70 is. So if you want, you can indicate that as your 70 here. This is your 70 degrees. To form 90, and then you complete the diagram like that. When you complete the diagram like that, you'll see that this will be your t, and this will be your square root of 1 minus t squared. Then you can be able to then do your you find your sine 70. But I have decided to do it like this. So remember, sine 70, it's a cofunction with what? With cos. Why? 70 plus 20 is equals to 90. So remember, if the two angles add up to 90, it means I can change sine to cos. So the minus sign still stays as it is, and then sine changes to cos, and then 70 changes to what? To 20. So like we did earlier on, we had cos cos 90 minus theta. So cos 90 minus theta changes, cos changes to sine, and 90 minus theta changes to what? To theta. So that is what you use over here, and which is what we used on the previous exercises whenever we had the two angles adding up to 90. So you change the one and write it in terms of the other one. Okay, so just be careful for these ones. They can be a bit confusing. So just remember, if you check this 20, this 70 and the 20 that is given. So 70 and 20, the one that was given, they add up to what? To 90. So that means I can change the sign to cos, and then instead of the 70, I write the 20, because they are in this relationship that we have indicated there. Okay, so then cos 20 is t, and then your final answer will then be minus t. All right, so please do exercise 5, everything. That means number 1, number 2, number 3. And so you're just going to have 3 diagrams, and then you do that. Okay, thank you.